This video will cover Chapter 10, Section 4, Zero and Negative Exponents. The standard that aligns with this video is 8.EE.1. The objective of this video is to use the properties of integer exponents to generate equivalent expressions. For any non-zero number a to the 0 power is going to be equal to 1. 0 to the 0 power is undefined. So, if we had 4 to the 0 power, it will be equal to 1. Because 4 is not 0, so anything to the 0 power is going to be equal to 1, except for 0. A to the negative n power, when a does not equal 0, is going to be the same as 1 over a to the nth power. Let's do an example. Here we have 3 to the negative 4th power. Because the 4 is negative, this is the same as 1 over 3 to the 4th power, which is equal to 1 over 3 multiplied by itself 4 times, because 3 is our base. We have our factor equal to 3. And because 4 is our exponent, we multiply 3 by itself 4 times. 3 multiplied by 3 is equal to 9. And 3 multiplied by 3 is equal to 9. So 9 multiplied by 9 is equal to 81. This is the same as 3 to the 4th power. So we can rewrite this as 1 over 81. Let's try another more complicated example. Here we are going to evaluate the expression. As you remember before, when we have two powers multiplied by each other with the same base, and here we see our base is negative 8 for both, then we add the powers together. So here we add the power 4 and negative 4 to each other. So we rewrite our power of negative 8 because the base is the same, and because they're multiplied, we're going to add 4 and negative 4. Now, since it's already negative, we're going to leave it as negative because a positive multiplied by a negative is going to be a negative. This is the same as negative 8, to the 0 power, because 4 minus 4 is equal to 0. Now, anything raised to the 0 power that is not 0 is going to always be 1. So our answer is 1. Let's try evaluating this expression. Here we have 2 to the 6th power divided by 2 to the 8th power. Now, as you remember from our previous videos, if it has the same base, which here we see our base is 2, we rewrite our base, and because they are divided by each other, we would take the top, which is 6, and subtract it from the bottom, which is 8. Now, 6 minus 8 is negative 2. So our answer is now 2 to the negative 2 power. Now, because our exponent is negative, we would say that this is the same as 1 over 2 squared. Let's try evaluating this expression. Here we see negative 5, which does not have a power, multiplied by x to the 0th power. Now, as we said before, anything to the 0 power besides 0 is going to be 1. So even a variable raised to the 0th power is going to be 1. So we can substitute 1 in for x to the 0th power. So this is the same as negative 5 multiplied by 1, which equals negative 5. Let's try one last example. Let's evaluate this expression. Here we have 9 multiplied by y to the negative third power divided by y to the fifth power. Now, as we said before, when it has the same base, which here we see it's y, we're going to keep the base of y, and we're going to take the top and subtract the bottom. So our top is negative 3, and we're going to subtract the bottom of 5. So this is the same as 9y to the negative 8th power, because negative 3 minus 5 is negative 8. And we would change this because we have our negative power to 9. This stays on top because it does not have a negative power. And y to the 8th power goes on the bottom to get rid of the negative in the power. And this would be our final answer. For further assistance, read pages 430 through 431. Tonight you must also do the homework problems on page 432, numbers 5, 6, 8, 9, 10, and 11. This is due before the beginning of class. These will be turned in at the beginning of class on Friday, September 18th.